Hello, everyone, and welcome to our today's Quanser webinar. My name is Zuzana Fabushova, and together with my colleague Peter Martin, R&D Manager of Academic Applications, we will be your hosts and webinar moderators today.
Good morning, everybody. Thank you very much for coming. I hope that you're doing well today and keeping healthy and safe. This is the second webinar we've done related to this topic of distance learning, blended engineering education, and also bringing in our new digital experiences collection of products, including the Quanser Interactive Labs platform that I'll be talking about a little bit today in preparation for our launch of the product coming next week. I hope some of you have tried the free trial that we've had for the last few months and have gotten some experience with the platform, and I'm excited to show you some of the developments that we've been working on and give you a little bit of a glimpse of what's to come. So if you're not familiar with Quanser Interactive Labs, what we have done is basically created what we believe is an unparalleled platform for engineering education at a distance, and also for blended engineering education in terms of using both digital assets as well as your traditional classroom learning experiences. And we really believe that this is a platform that is not just going to be useful or be a really great solution to the problems that we all have now in terms of having to more and more provide distance solutions for our partners and our colleagues around the world, but also a platform that will live on and become a legacy of what we do at Quanser. And so I'm going to sort of start there in terms of what we do at Quanser. A lot of you, I hope, are familiar with us, but the way that I like to start talking about Quanser is to talk about this particular question: how do we prepare the next generation of engineering leadership? And that's a very particular question to me because it speaks not only to the products that we prepare, that we create, and that we release, that probably a lot of you are familiar with, things like servo motors and robots and things like that, our hardware experiences, but also the elements of what we do as a company, not only on the software side and the curriculum side, but how we work with our partners and colleagues and how we try to make sure that everyone can fulfill this ultimate goal of creating this engineering leadership. And with that, it's a lot of building not only, as I said, the tools that are required to be able to provide these sorts of learning experiences for students, but also fundamentally the skills that they need to be able to take on the challenges that you can see here, the challenges that we see coming over the next few years and decades, and build the intuition and the experiences that they need to be able to come into these sorts of challenges and excel and succeed, whether it be in academia or in industry. We really try to provide a full solution that can enable our partners to be able to give those solutions to students. But with that comes a little bit of a challenge in terms of being able to provide those sorts of learning experiences, be able to provide that kind of effective skills-based learning for students when you're not on campus, when you can't follow that traditional flow of being able to provide these sorts of experiences to students in the classroom or in the lab. And we've talked about this before. A lot of our partners came to us earlier this year, as you can imagine, looking for a solution to this particular question, looking for sort of facing the challenge of how can we take our approach to learning and take it online, take it off campus, and be able to provide the same effective experiences for students to maintain not only the experience of students and give them the experience that they've come to expect out of these institutions, but also maintain the credibility and the reputation of the institutions in terms of being a place where students can come for really modern and engaging and effective learning, but also at the same time to be able to give those experiences to students in a way that may be even better than their traditional experiences on campus, to be able to augment what's typically done on campus with experiences that can really give them a different view of how engineering works and how, especially complex systems like we typically deal with in terms of controls and mechatronics and robotics, how those systems can come alive if you look at them from a different perspective than you might get typically on campus. So when we took on this challenge months ago, not too many months ago at this point, probably about 3 or 4 months ago, we started this project. We looked at how can we provide these digital experiences? How can we create a solution to that particular problem of how our partners can take their courses online, but also the previous challenge of how can we also make sure that whatever we do provide still maintains that level of efficacy, that level of modernity that can really give students the skills they need to have that leadership potential. And so what we did was we looked at our legacy and our technological pillars as a company. As I said previously, you're probably very familiar with our hardware legacy, our ability to create these cutting edge, forward-looking hardware platforms. Also, a lot of you are very familiar with the underpinnings of how we provide those hardware experiences with our Quark real-time platform. And some of you, again, also might be familiar with the QDex platform, our mobile-based content distribution platform that really gives educators and students experiences that are unlike any other in terms of being able to really interact and engage with content. And then finally, our virtualization element of what we do as a company that's a little bit less known. It's not quite as has been publicly released or as productionized as you might expect, but at the same time, it's underpinned a lot of what we've done, not only in being able to show experiences in terms of videos, but also a lot of what we've done over the years in terms of demonstrations, in terms of being able to build that virtualization platform into how we design and develop products, how some of our more cutting edge research products like the self-driving car research studio can affect these types of experiences, but then also some of the cutting edge and forward-looking projects we've worked on with some of our partners I'll talk about in a second. So all these elements we looked at as means to be able to provide answers to those two previous questions. And what we started to do was look at not just individual elements of this diagram, but also how they blend together, how we can combine our online content platform with virtualization, how we can combine our hardware and real-time platforms with virtualization alongside content, and how we could blend all of these together. What you might remember from last year and from earlier this year is a couple of different things that we did, but what we wanted to underpin all of this with were these main points for how this type of platform would be delivered, these sort of ethos of how our digital experiences should be provided. The first, as I said, was a cutting edge approach to being able to provide not just content and lab management and distribution, but make sure that that was provided for different contexts, whether it be in the lab, in the lecture, living rooms, online, offline, across multiple platforms. So making sure that it was as accessible as possible for all types of students in different scenarios, but also that the solutions themselves were specifically designed for the needs of various courses and activities. So not just creating a generic collection of material or a single platform to do everything, but fine tune exactly what the content and experiences were for very particular aspects of how students move through their overall learning experience of coming into a classroom and it controls a robotics course, and then also how they move through that class, whether it be looking at resources, lectures, labs, at home, all the different aspects of what students do in a course. The first real incantation of this was when we created Experience Controls, our digital textbook, at the end of last year. Over the one full academic year that we've had since then, we saw over 5,500 downloads with 450 instructor resource downloads. And you can see here from some of the comments that we got back from students primarily, there really was an appetite. This really showed that students were engaged and interested in this type of innovative platform for being able to connect with traditional resources that would typically be provided in something like a paperback textbook, but being able to really engage and really understand and interact with these platforms and these experiences. There was an appetite there, and this really showed us that that kind of experience would be something of great value in this type of context. As I said, to take not only the classrooms offline, but also to augment traditional classrooms. And at the same time, we did a lot of work over the last few months with one of our partners here in Canada to be able to provide solutions like this for changing how they provide their first year engineering experiences, where students don't just sort of come into first year and get a basic experience of being able to sort of learn about electronics and mathematics and that kind of thing, but also to really engage and understand how engineering comes together at a system level. So you can see here, we have one of our ground robots moving through a virtual environment. But what this demonstrates is for students coming into first year, the excitement of engineering, how engineering can be applied in different ways, how they can take on different challenges, how different aspects of what they learn over the years, especially in first and second year, can be applied to complex challenges. And we were able to provide a virtual environment to give them that application context, which is really motivational and really essential to being able to especially engage with incoming students to show how engineering really comes alive in this kind of warehouse context and make it flexible and adaptable for different challenges. But as you can see with those two examples, they're sort of single circles of that Venn diagram where we're either doing digital content or we're doing the virtual experiences. What we wanted to do, as I said, was bring all of those together into a package to make it that unparalleled platform, to make it that learning experience and that platform that would be flexible enough to address a number of different courses, a number of different elements of how people want to be able to teach their students and give them these types of experiences. And so what we did was create interactive labs, which I had talked about a couple of months ago for the first time when we introduced our free trial. I hope some of you had an experience, as I said, with that free trial over the last couple of months. But what we wanted to do was bring all of those circles together into the only hardware-inspired way to bring these high-fidelity lab experiences to students off campus. And that hardware-inspired is really essential to what we did. Again, bringing in all of those circles of that Venn diagram to really focus it on our hardware experiences, which we've been doing for over 30 years, because we really fundamentally believe that that hardware experience is essential, and that being able to give students experiences based around hardware, based around how physical systems work in the real world, is an essential part of being able to understand how engineering comes together, whether it be in controls or robotics or other applications of engineering education. And at the same time, to be able to give them as close as possible the experience that they would expect on campus, and also one that was, as I said, a little bit more rich, a little bit more uh, interesting and engaging and enlightening than it would have been typically even with our traditional experiences. And so I'll start by in terms of talking about interactive labs at the beginning, at the same place that everyone begins their interactive labs experience, which is on the digital portal, the academic portal, where everybody essentially has to come as their first step, whether it be an instructor or a student. This is where you come to register, to sign up, to access the session that you may have talked to a salesperson about. To students would come here to register and to get access to a particular classroom session. This is where statistics live if you want to see how your students are using the platform and interacting with it. That being said, there are a number of other ways that they can interact with the platform. This is the typical instructor workflow, where I'm starting a little bit ahead of the academic portal, where you would actually come as you normally would to a Quanser associate, to one of our sales team or our distributors, to really allow us to understand exactly what your challenge is, exactly what your course is, how you want to provide these experiences to students, what types of hardware experiences are essential, how you believe that students should interact with those in terms of your syllabus and the outcomes you want them to have. And based on that, we can really craft a solution that is the most effective for your particular interest, for your particular application. And then, as I said, moving next to the academic portal where you can access that solution that you purchased. And then also for students, they can kind of bypass that whole workflow to make it as easy as possible for students to get access, where once you have your session set up, all students have to do, at least in terms of the what we call the essential labs, the laboratory experiences that include the mobile content, is just download our mobile app and register. And as soon as they register, as long as they're part of your session, all their content's unlocked and they're ready to go. There's nothing else is required. So then finally, as you can see here, is on the desktop app, but also across the board, they all end up in either a Windows or a mobile experience, depending on the type of product. And again, the experience is very simple. You log in or register, and then all your content is ready to go and you can get started immediately. And then when I talk a little bit about the virtual solutions in a second, you'll see that experience also is as simple and straightforward as we could make it to really try to make this experience one that's, as I said, accessible, that's applicable to a number of different situations, and is one that can be flexible and can grow over the years as well. And so to start with the simplicity, the most straightforward solution, I'll start by talking about what we're calling QLabs controls, which is our controls product family, our controls package for the Quanser Interactive Labs platform. And this, as I said, is really the turnkey solution. This is the one where you don't need any IT support, you don't need any on-campus resources. It's extremely simple just to contact us. As I said, let us talk a little bit about exactly what you need, and then be able to provide that solution to students without any real customization or any real requirements for them to do anything except download the Windows, macOS, or iOS and Android apps and get started immediately. That being said, it isn't necessarily, because it's simple, it doesn't mean it has any less of the interactivity and the engagement that we would expect. The platform, as you can see here on the left-hand side on desktop and on the right-hand side on mobile, is a very rich experience where they can interact with our plants exactly as they would the real systems. They can take measurements. Coming soon, they'll be able to download the data sets and analyze them in different tool sets. On mobile coming soon, they'll be able to do the assessment questions you can see here and submit them through email or through Google Drive. But across the board, across the platforms, the experience is the same, going through the curriculum, answering the questions, being able to analyze the systems and tune them and understand how these hardware systems come together. That experience is maintained. So again, it's as accessible and easy to use as possible. And that being said, again, even though it is simple, accessible, and easy to use, we have a full complement of curriculum modules that we've created specifically for control systems for this platform. This isn't even all of them. I'll show you some more in a second. Over 20 lab hours, altogether over 30 lab hours of activities for students. And these are custom designed for this platform. They're not the same experiences. They're very close, but they're not exactly the same experiences that students would expect to have with our traditional hardware. These are fine-tuned to be able to really highlight and emphasize that laboratory experience, that interactivity with hardware to really understand what hardware brings to the table and how control systems are affected by things like noise or stability or different dynamics, or how creating a control system and applying it might need further tuning or modification or introduction of different things like integrals or filtering to be able to really function the way that you expect. And so that was why we really tuned these experiences. And then at the same time, you can see here, we also introduced some more forward-looking applications for things like aerospace, where students could get into things like nonlinear control or optimal control systems that are more applicable to complex control problems. And with that comes, again, a little bit of interesting insight into how control systems works in different ways in different places. But all of that, very simple to use, very easy, very interactive and engaging for students, whether they're on the bus or they're in their living room or even they're on campus or in a lecture. They can see these experiences and really use them and understand how these work. And there's no more oversight or requirements for anything like you would typically require with something like a remote lab, for instance. We talked a lot when we came into this project about how remote labs could be a solution to this problem, but myself, having come from over a decade of working with remote laboratory experiences, as well as our experience as a company for many, many years, building solutions that were remote lab capable, we didn't really see that as being the most effective way to bring these experiences to students, not only because as much as hardware is always, as you can well imagine from what we do as a company, where we think the best learning happens, it isn't necessarily the easiest experiences. There's always hiccups, there's always complications, there's always requirements for maintenance, for oversight, for security concerns, for privacy concerns. And with all of that comes a lot of overhead and a lot of spin up and development on the customer side, which, especially if you're not on campus, is extremely challenging. And so with that, we really saw this virtualized experience, the one I showed you just now and the one that I'll show you in a second, as being the most effective way to deliver these solutions right now, and also the most effective way to complement on-campus solutions. And so you can see here the types of packages we've created for QLabs controls. The first is an introductory package, sort of the good of the good, better, best set of solutions. In this case, it's the one that deals with the classic controls topics, what you would essentially be able to do on a typical servo motor, to really understand the basics of control systems and how control systems are created, designed, modeled, and then tuned and implemented. In that case, it includes still 7 curriculum modules that cover the breadth of introductory controls courses. There's over 12 hours of lab exercises. And as with all of our subscriptions, that can be provided for a 12-month package to students. In that case, it's up to 150, but as you can see, the number of seats available grows as you move through the packages. And all of them come with instructor resources and that statistics and analytics section where you can actually see how students are using the platform and understand how they're doing and check in on how they're understanding the problems and how effectively they're moving towards those ultimate outcomes that your syllabus would want them to be able to understand. And then moving to the second package, QLabs controls, we add in not just the pendulum for the servo system, but also the aerospace platform, which brings the total up to over 15 curriculum modules with 30 lab hours. And that introduces more seats as well as access to new curriculum modules. I say over 30 lab hours with over 15 curriculum modules because we do expect this collection to grow. We have at least 4 or 5 curriculum modules that we have on the books that we'd like to create, but we just didn't quite get them finished for our release next week. And so those will be coming hopefully the next few months. And with those, if you have the QLabs controls or QLabs controls Premier packages, those would be provided immediately to you and your students. And that also at that middle tier level does start to introduce things like hardware discounts and incentives where at the time of purchase, you can actually bundle in a QUBE-Servo 2 or an AERO in physicality. And you can, there are discounts there that would really give a full rounded experience for students. And then finally at the Premier level, that introduces priority support, which we don't expect you to need support, but if you do, we'd be able to provide it as quickly and as bespoke to you and your problems as possible. And it also includes not just a hardware discount, which again, once you get back on campus is a great incentive, but also a virtual QUBE-Servo 2 and virtual Quanser AERO, which I'll show you some examples of in a second. And that really brings the whole package together for not only being able to have students create their own control systems for the QUBE-Servo and for the AERO using platforms like MATLAB Simulink, but also introduces, because with those virtual platforms, they're compatible with all of our existing curriculum, another 50 or more curriculum topics that can be covered out of our existing material we've been building up for the last years. And so that's really a fantastic platform where you have all of the lab activities for students using QLabs controls, whatever platform they want to use, wherever they are in the world. And it introduces the ability for them to also create their own controllers using MATLAB Simulink or other platforms. And then finally, hardware discounts on real hardware. So you get the full package of every experience you could possibly have your students, give your students with this type of platform. But then moving on from QLabs controls, we get to, again, talking about that last point I had for that, what we wanted to do with digital experiences, a different solution for a different problem. So in this case, we really believed that for control systems, this parametric approach of having a very straightforward way for students to understand how control systems behave in a hardware environment was essential. But with control systems, typically creating the controllers, really living, for lack of a better phrase, on the block diagram is not necessarily essential to understanding control systems. But with something like robotics, that is an essential part of how robotics comes together. You can't as effectively teach robotics, especially in a laboratory context, without giving students the ability to create the algorithms, to really craft them and understand how the different subsystems of a robotic platform interact and how the different systems play together, pass data, how introducing issues or problems into different parts of the system can cascade down through something like a manipulator or a mobile robot, and also how your algorithms at different points in the system can play together and share information. And so what's essential in that case, as I said, is creating it. And so what we did with QLabs Robotics, which will also be coming next week at the end of this month, was create a situation where students for the first time have access to their own mobile robot and their own manipulator at home, which is a fundamentally paradigm shift in how robotics is provided the laboratory experience. I don't think I've ever heard of an institution or a course in robotics where students each get their own versatile mobile platform and manipulator system to work with and to really craft and create exactly the algorithms they want to try and play with them in different contexts and different environments, whether it be on a table or in a sandbox in the mobile environment, as you can see here, but then also hopefully over the next few months introducing other environments. It's a unique experience for students, and one that is really complementary long-term to traditional scenarios for robotics education. And so what we did was create these digital twins of our two fundamental robot platforms, the QBot 2E and the QArm. They're fully instrumented, dynamically accurate. They have all the sensors that you would typically expect them to have, or that they would really have in their physical form. But then they're completely compatible with MATLAB and Simulink using a new version of our Quark platform. And with that comes the ability for you not just to use them to build up lab experiences for students, but also, again, as I talked about a second ago with the QUBE-Servo and the AERO platforms, you can repurpose all of our existing materials. So if you've created algorithms for QBot 2, probably not for QArm since it's actually not released yet as a hardware product, but if you created algorithms for QBot 2, they should be seamlessly portable to the virtual platform. And as we start to release the hardware version of QArm over the next few months, you'll also be able to port those very seamlessly from the manipulator system in physicality to the virtual systems. And that kind of process, how that works, looks something like this, where the first step would be to install Quanser Interactive Labs for Windows. Unfortunately, this is only available for Windows because of all of the requirements we have for being able to provide this solution and have it behave reliably in real time and give the right sensor measurements and have the whole chain between your code and the virtual system work effectively. So the first step would be installing that particular system. If you have MATLAB Simulink installed, then it'll go the next step to installing Quark Home, which is our Quark version for this particular platform that speaks directly to these virtual systems. But what that does is allow you on this second step to open any of your code, add new code, existing platforms that we provided, existing solutions that you've created, and update that ever so slightly in step 3 so it can talk to the virtual system just by adding an IP address that points at your local system where the virtual lab lives, as you can see there. And then as soon as you open the module in Quanser Interactive Labs, it'll seamlessly spawn a dynamic model that runs in real time in the background to make sure that all the dynamics of the system are done effectively and the interactivity and the sensor signals or everything are passed back and forth effectively. And then you just run your code in normal mode, which if you know how MATLAB Simulink works is also new for us. There's no need to compile or download or run external mode or anything like that. You just press play and it will connect and run and everything is running as you would expect and as the real hardware would. But then finally in step 6, there's that last step of, to us especially, nothing beats the real hardware experience. And so any of the algorithms you would create over this process for our virtual systems should be directly portable to the actual hardware. So finally, if you want to validate algorithms you've created for capstone projects, for project-based learning, even for master's level research and things like that, those should be immediately portable to our actual hardware platforms where you can actually get the real data and the real experience in real time on those types of platforms. And so this is a little bit like what this whole process looks like. This is one of my colleagues who in the background has the curriculum applications for the Quanser ARM. He's gone into Quanser Interactive Labs. In this case, it's one of our beta versions of it. And that's immediately, as you can see from the console, spawned that real-time dynamic model. He's just going to go ahead and run his code in normal mode. Again, this is just the off-the-shelf code designed for the actual physical machine. And the virtual machine, exactly as a physical machine would, starts to behave exactly the same way. It's doing a pick and place task in this case, but as you can see in the background, he's just commanding the virtual arm the same way he would command the actual arm, and everything else is taken care of, making sure that all the dynamics work properly, making sure that all the controllers work properly, unless he wants to create his own controllers. And that, as you can see with the Quanser arm, things like the additional sensors we've included with the Intel RealSense camera work effectively as well. So you can also stream video and depth data back and forth as well to start introducing some exciting concepts like visual servoing and things like that, which I'll talk about in a second when I get to the curriculum. But I just want to pause for 1 second to talk a little bit more about the Quanser ARM, the QArm, because as I said, this is an unreleased hardware product. This, strangely enough, with the new world order, will be coming after our virtual representation of this product, probably later this fall. And so what we've done with this product, with the QArm, is create a forward-off manipulator with a two-stage tendon-based gripper. So what we did was really truly try to create a platform that was designed specifically for not just modern robotics, not just things like machine learning and other emerging aspects of how you would use a manipulator system, but also specifically designed for modern approaches to teaching robotics, whether it's studio-based learning or project-based learning or capstones or however you want students to really interact and understand how manipulators work. We created this specifically for that particular application. And at the same time, it has all the capabilities you would need out of a manipulator system, the payload, the velocities, all of the sensor signals you can get from the different joints, a really nice, effective workspace, and also our full Quanser curriculum we would traditionally provide with a system like this to be able to map to the traditional textbooks of Spong and Craig to be able to provide a fantastic solution for academic applications of robotic systems. You can see here all of the typical curriculum topics are included, from introduction to the platform itself and how manipulators work to the basics of joint control, kinematics, path planning, then getting into some more complex aspects like statistics and dynamics. It really covers all of those touch points of robotics. But again, these are all provided not only for the real system, but also for the virtual system, to really have that mapping and have, again, students able to create and work with their own manipulator. This is a full package of over 25 lab hours for the manipulator system. But then, as you can see here, we also introduce the ground robot as well to really truly complete that full solution for robotics courses. And here you can see with the robot on the top left, we're also, in this case, streaming the video from the Kinect sensor in terms of just your typical RGB video, as well as the depth sensor measurements. The bump sensors in the front of the robot are functional. So you can see it running into walls, kind of like your traditional robotic vacuum would work. There's different camera views. You can augment these experiences to have an experience for students unlike any that they would have traditionally, in terms of being able to maybe introduce capabilities or augmented aspects of this experience that might not be able to experience in the real world. But for the QBot 2 itself, if you're not familiar with the QBot 2, it is basically a versatile and open architecture ground robot. So it's really a blank canvas of being able to create whatever algorithm students might want to be able to work with on a platform that's robust and versatile, that has your RGBD vision system for more advanced applications of mapping and localization, but then a wide complementary range of sensors on board as well, in terms of bump sensors and wheel drop and cliff sensors and gyroscopes and all sorts of other sensors that are included in the platform itself as well. Out of the box on the first release of this platform, I believe we're supporting the gyroscope and the bump sensor, but more will be coming down the road as well in that respect. Excuse me. In terms of how we complement that with the curriculum, this is our traditional QBot 2E curriculum that we designed in collaboration with universities here in Canada to really address the needs of an undergraduate mobile robotics course. So again, we start with an introduction to the platform, an introduction to mobile robotics. We let students play with the system to really get excited by it and understand motivationally how this type of platform comes together. But then we move into things like kinematics, including odometric localization and aspects of mapping, using a number of different approaches to mapping, computer vision, using a number of different approaches to not just using computer vision to understand data coming from a camera, but also what you do with that information in terms of things like line following. And then finally getting into path planning in terms of different approaches to how you would create and navigate an environment. So we really go start to finish through the experience of a mobile robot, from where the robot is, what happens when it moves, what it needs to do to get to its destination, and then how it moves that destination by avoiding obstacles and things like that. So the full system of how a mobile robot functions is completely covered with this curriculum. And again, this is the same curriculum on the physical system as we're providing for the virtual system. And so for all of that, for the arm, for the ground robot, for the full experience, We have a single package now. We're hoping to provide some additional packages coming later this year to really round out the full complement of solutions for different situations that you might have depending on your course and your outcomes and your needs. But this still offers a fantastic range of curriculum topics, of hours of lab exercises. It's the same 12-month duration, the same 300 seats. The instructor resources and new content modules is all basically part of what we would typically provide for our physical systems, which is included here as well. And as I said, it's compatible now with MATLAB Simulink, and then hopefully coming later this year with other platforms that we want to make compatible as well, maybe things like Python or LabVIEW or other approaches to how you would want to talk to a robotic system. And in terms of that forward-looking, what we have coming later this year, I'll close by just talking about our current timeline. So again, as I said, next week we'll be launching these first QLabs packages, the QLabs controls and QLabs robotics. They'll include the QUBE-Servo 2, the Quanser AERO, the QArm, and the QBot 2E. With those two approaches, the virtual approach and the parametric approach, what we call the Essentials Labs. They'll both have full curriculum, and then later this month we'll be including the statistics as well. As when I say full curriculum, that'll also be coming in the next few weeks. We have a very rich, complementary, and representative set of curriculum launching next week on Monday, so that will be available immediately. But then some of the more advanced topics, some of the topics that would typically come later in a course, will be launching in the next few weeks just to make sure that they're polished and they're giving the right experience. So those will be coming not long after, but not quite day one next week. On August 1st, we're also going to be hopefully releasing the virtual QUBE-Servo 2 and the virtual Quanser AERO that I talked about as part of the Controls Premier package. So that will bring MATLAB and Simulink support to the QUBE-Servo 2 and the Quanser AERO, the same way as the robots, where it's the same experience as the physical hardware. All of our existing curriculum is immediately able to get ported to that platform without very much change, very much modification. And then moving on from August to the September timeframe, we're going to start to create what we're calling a studio solution, where we have a number of other hardware plants virtualized that can be all sort of put together in a full complementary package, exactly as we would typically bundle all of our hardware together to really round out and create a fantastic laboratory full of virtual equipment, whether it be the couple tanks or our traditional servo base unit, a ball and beam experience to bring a little bit of a different dynamic feel and controls structure, and then our flexible link again to change the dynamics slightly again. But then also at that time frame, we want to possibly release a more flexible and expansive robotics premier package that might bring other experiences, like being able to potentially collaborate between robots or have more free and challenging environments for the robots to live in and to take on different problems or different projects or things like that. And then moving again further into the fall towards the end of the year, we'd like to take all of these virtual plants that we've created, all these virtual digital twins of our hardware, and provide more flexible packages where you can mix and match the hardware that you want to really be able to replicate what you have on campus and the experiences that students have on campus, again, with the additional benefits of being able to give a unit to every student and give them the experiences that come from the full complement of materials and packages, as well as hopefully we're providing more support for other languages to talk to them and things like that later in the year as well. So you can see the timeline is growing in terms of the number of products we have available. It's growing in terms of the flexibility of how those products can be used, but also it's growing in terms of how they can be packaged and mixed and matched to really provide effective solutions for exactly the challenges that you're looking at for your courses. And in terms of those challenges, if you have any questions for us, I'm happy to take the questions now, or you can feel free to contact us at info@quanser.com, and we're happy to help to figure out exactly what package, what collection of materials is right for you and what you're looking at in terms of your challenges for your students.
So I will start with a couple that we received already. And this one is related to QLabs controls. How are you planning, or are you planning to incorporate more advanced controls topics?
So for the advanced controls topics, it really depends on what the topic is and what's necessary for students to really get an experience dealing with that type of topic. So for instance, the initial package, the QUBE-Servo 2 that's part of the classic bundle for QLabs controls, obviously that doesn't really get into what you would typically call an advanced topic in terms of you're really dealing with the basics of modeling, PID controller design, control of a servo motor, things like that, stability and second order systems analysis and stuff like that. And then with the main package, we introduce some of the aspects of what you might call advanced. I mean, nowadays, modern control is not exactly an advanced topic, but we do get into state-space modeling and pole placement and some more advanced control structures and things like that. And then with the aerospace platform, we introduced nonlinear control to a certain extent with gain scheduling, as well as optimal control of the different configurations of the AERO using LQR and things like that. So that is getting quite up there in terms of complexity. And then obviously with the virtual plants, there's the ability to introduce even more complex control structures in MATLAB and Simulink that can talk to those same systems. We do have another complement of labs that we'd like to introduce that will take that even further in terms of really diving deep on optimal control, getting into observers and things like that. But again, if the student for the QLabs controls experience really just needs to understand parametrically how the elements of the control system affect the behavior of the plant, all of that is 100% possible with the QLabs controls package. There's no need for them to necessarily create the controller or create the structure to understand how it works and how it's implemented and what it does to the real hardware. But if that is an essential part of the advanced control application, then the virtual plants take over where they can actually create their own solutions, things like that as well.
Okay, another set of questions about trial for the QLabs. I have a class in the fall with about 25 students. Can we have access to trial version and then look at it during the summer?
Honestly, that would be a question for our sales team at info@quanser.com. We will be packaging trial versions of these platforms that will make available as demonstrations where you can use them with your students and you can get a feel for the platform and understand how it could work to really meet the needs that you have. But I don't know, to be honest, exactly what the restrictions on those would be in terms of time or in terms of the number of seats or the availability. I'm not entirely sure, so that would be a great question to follow up with our sales team to really get a package or a demonstration that'll work for you.
Okay,
Hi, Susanna. I can jump in on that one as well. Hi, everyone. So just to elaborate on what Peter was saying, definitely we want to enable all potential users to get trial access, and please send us an email for now at info@quanser.com, and then we will be able to get you set up with a trial access to the various modules that you saw Peter present, and then moving forward, we'll make that a bit more streamlined. But for now, we'd love to hear from you and what your needs are, and we can get you up and running to try out the software.
Thank you, Paul. How do you define a lab hour?
That's an excellent question. And that's been an interesting challenge for us. So for our traditional labs, the way that we would typically do it is we would have our interns and co-op students run through the curriculum and keep track of how long it took them fresh coming into the company, but as undergraduate engineering students to go through the material. We've also in the past even had high school students who are particularly advanced getting towards the later stages of their education to go through the material as well. For some of these labs we've created from scratch, especially in this scenario where we don't necessarily have co-ops and interns anymore since we're all at home, it's been a little bit more of a challenge, but we've basically partly taken the approach that you might typically take when you're creating an exam or a midterm for your students, where we would go through the material, keep track of how long it takes us to complete it, and then multiply that time by 4 or 5, just to sort of get a more representative experience for how long it would take a student to realistically go through the material. Especially nowadays, if they're off campus, if they're at home, that might even be more time consuming because there's more distractions, obviously, than there would be on campus. But that's sort of where we start with and how we traditionally kind of pull this material together. We've had this material go through a lot of different courses, a lot of different institutions, and we've gone through it a lot ourselves with our incoming engineers into Quanser as well. This material is how we train our own staff. So we're pretty familiar with how long it takes to go through our traditional material, and that also informed the numbers in terms of how long we expect it to take to go through the new material that we've created. But you're absolutely right. It's always relative.
Thank you. The next question, there are some assessments included in the curriculum. Do you publish their solutions? And can instructors define their own practice problems?
On both cases, yes, absolutely. We publish all the instructor material, and you can reach out to us as you would any of our instructor material, whether it's at tech@quanser.com or info@quanser.com, and we can send you a link to download the instructor material. If you want to customize the assessment, obviously that's also 100% an option. For QLabs controls, when you use the mobile version, obviously the curriculum is packaged up into the mobile experience. But if you use the desktop version for Windows or for macOS, it's provided completely open as a Word document and as a PDF that you can either give to your students, or you can customize obviously those documents to provide them to your students either through your traditional LMS system or through email or however you like. With the mobile platform, we're hoping in the next few weeks to be able to provide the ability for students to submit lab reports directly from the mobile platform, like I said, either through email or Google Drive. Those would obviously be the solutions to the questions that are included. But again, if you'd like your students to be able to provide those in another way to different questions, that's obviously possible as well. And also with the virtual plants, the exact same experience you would have on campus in your lab is the same experience students can have at home or off campus. So there's a lot of versatility there. The only real element of what we provide for the curriculum that's closed would be the curriculum that's included inside the mobile applications. But even there, students don't necessarily have to go through the complete experience if you'd like to customize it.
Thank you. Next question, can QLab controls be connected to external equipment?
Yeah, so that's the question we get a lot. And I sort of touched on that a little bit earlier in terms of our remote lab solutions. So that is possible. It's a technologically possible. We don't at the moment have a solution that we could recommend to be able to make that something that we'd want you to necessarily take on, just because the timing, as you can imagine, of being able to have a virtual system interacting with a real-time dynamic model, interacting with the user code that you or we are creating, is very complex and very nuanced. And right now we're trying as much as possible to control all the different interconnections between those elements to make sure that everything works the way that you would expect the real hardware to work. That isn't to say that in the future we might not be able to come up with solutions to make that possible, but at the moment that isn't something that we have available. But we could definitely work with you if you reach out to us to try to come up with a solution. As PK always mentions, all of our hardware experiences, all of our traditional hardware is remote lab ready. So that might be another complementary experience. You can see from our experience controls textbook as well, with the hardware experiences there, that connecting and using our hardware remotely is definitely possible. And these virtual systems eventually, we hope, will behave in the same way, but we're not quite there yet in terms of making sure the experience is robust.
Thanks, Peter. This is Paul here as well. So just to expand on that, and I'm seeing some of the questions coming in. So maybe just to elaborate, some of the virtual labs that Peter has been presenting, specifically showing you the robotics, but also some of our other products coming down the pipe. Our intent is to make them as close as possible to the physical lab experience, meaning if you already have a Quanser product, be it a QUBE, an AERO, the upcoming ARM, or so on, the experience with the virtual labs and the interactive labs within that paradigm should be as close to possible as the physical. So instead of plugging in your QUBE into your computer via USB, you're simply double clicking on it through Quanser Interactive Labs, and it's being served up to you on your screen as opposed to being physically on your desk. And then the hardware, the software environment around it, we expect to be the exact same. And that's the whole intent, is that all these interactions, all these virtual virtualizations and virtual labs that the students can have access to on their own time, on their own PCs, should complement the access and the experience in the lab with the physical system as well. So for those of you who are aware of Quanser's software architecture, all our physical systems are open architecture, and our software has an open framework so that you can connect to it via C++, Python, ROS in some cases, and so on. But the predominant user interface, and the one that we document quite heavily and focus on to start, is the MATLAB Simulink interface. So at the start, you will see a lot of MATLAB Simulink examples, and definitely leveraging all our existing MATLAB and Simulink experiences around all our products are immediately applicable to the virtual labs. And then moving forward, we will be giving more and more examples of other software environments, be it C, be it Python, and so on, that can also interact with the virtual lab. So hopefully that answers some of the questions in terms of software access to these systems.
Thanks, Paul. There is one more question that maybe you didn't touch on when you talk about the software. Is there's MATLAB version specific, or is there a specific MATLAB version the QLabs will be compatible with? Will that change every year, the same as it does with our other equipment, and compatibility with Quark in that sense?
So the compatibility, as you would imagine, is the same as Quark. So right now, our Quark platform supports MATLAB versions back to 2019A. And so this platform will also support MATLAB Simulink back to 2019A. And as you alluded to, over the years, we'll obviously move, because we fundamentally, as you can imagine, every year have to change the structure of Quark to be able to be compatible with the new and incoming versions of MATLAB Simulink. There is obviously a tail end that needs to sort of move in lockstep as well. So we try to maintain at least 1.5 full years of MATLAB Simulink. So right now we support 2019A to 2020A, and that moves. But at the same time, as with traditional Quark, if you really want to just stick with MATLAB 2019A and never upgrade, you can also, to a certain extent, stick with your particular version of Quanser Interactive Labs if it works for you and has the complements of features and modules that you need. But moving forward, again, just to make sure, especially in this case, with all the interconnections and all the different model rates and models and interactivity between the different parts of the system, we need to make sure they all work and blend and function well together. And so we'll be moving them forward in lockstep with MATLAB Simulink. But then, as Paul mentioned as well, if you down the road, maybe later this year, once we've had some time to build up support, want to use C++ or Python or another language to talk to the platform, that's a whole other option as well that's completely independent of having to stay in lockstep with MATLAB Simulink.
Thank you. Another question about the packages. Will renewing the QLabs controls classic yearly upgrade include the new curriculum modules, or
Yes.
will it remain the same with the initial modules?
Yeah. Basically, the way that Classic works is on the first day, or roughly at the beginning of your session, the curriculum package that's available is the one that you'll have for the duration of that session. But obviously, if you renew the next year, you'll have access to any of the material we created in the meantime. So 100% that will roll over and grow year after year, but just not immediately when it's ready.
Okay, are the seats in the subscription packages users in total or in parallel?
They are in total. So basically, those 300 seats, as you sign up students, as you add students to your session using the academic portal, as soon as the students register, then that seat is taken for the rest of the session for the rest of the year. So if you have a course in the spring of 100 students and a course in the fall of 100, maybe 150 students, that total for the year of 250 students, those would be the seats required. It wouldn't be necessary that you would sign up 100 students in the spring and then boot them all out and take those seats over again later on in the fall. It would be for the total year.
Okay. Does QLabs controls include Quark applications too?
So I think probably also talking to the previous question about MATLAB Simulink support. So the way that QLabs controls, so QLabs controls and the virtual plants as well, the way that they work is, so QLabs controls itself, that essentials package is completely standalone. It's essentially just built in the Unreal environment or in the mobile environment on Android and iOS. So that doesn't need any Quark, any MATLAB Simulink, anything at all to function. When you get into the virtual plants, because those open up the ability to interface from MATLAB, from Simulink, or from other platforms, that's when what we do is we introduce under the hood part of the what we do with Quark to be able to run those dynamic models in real time. Again, it doesn't mean that you necessarily, at least by the end of the year, hopefully, have to have MATLAB Simulink to use the virtual plants. Initially, that's the platform we're going to support, but that basically that's enabled through the Quark home that you install alongside the virtual plant, but not required down the road once we have other support. So there are elements of Quark that come into the virtual plants to let us run the dynamic models in real time and to let us at least from MATLAB Simulink open up the block diagrams without any additional Quark licenses, without any additional requirements for anything but what comes in the installer, and talk to those virtual plants from MATLAB Simulink. But again, once hopefully we get by the end of the year to supporting other means for creating your own code, then that Quark home element goes away, and basically there's just a little bit of our functionality under the hood to make sure the models run accurately. But everything else will be basically as flexible as we can make it.
Okay. Is it possible for students to work on a lab activity in a team?
That's another excellent question. Again, that's something we're looking at hopefully for the fall with the Robotics Premier package, where we'd like to make that possible. Again, that only increases the complexity of the communication and the number of elements of the platform that need to be in lockstep, but that is something that we hope to make possible. We have some examples of situations that we're already working on with some of our partner institutions where there are different elements, different systems in the same environment that can work together, that can talk and share information and all run independently. And at the moment, what I think we'd like to do is to be able to have those work seamlessly on a single system with a single student. But again, group work is always, especially in traditional labs, not necessarily means one device for every student. But again, moving forward, because of this virtual platform, because of what we're creating here with these digital twins, almost anything is possible. It's just a matter of time and a matter of being able to make sure the experience is exactly what we'd like to be able to provide.
Thank you. We are almost out of time, so I will ask Pete or Paul if they see any questions that they would specifically like to answer that I missed so far, or anything they would like to comment.
No, I mean, there are a few other ones, but we can probably take them offline and go directly back to the person who's asking the question. So I'd just like to take this opportunity to thanks again, Peter and Susanna, for putting together a fantastic webinar. Hopefully everyone on the call found it very useful, and yeah, we look forward. I mean, thank you for all the feedback in the trial that we released a few months ago, a short months ago, and we've gotten to a great place already because of that great feedback interaction you've given us. And now we're really looking forward to using, to working with you and utilizing this platform to meet your needs in the short term, but also as we mature this platform over the next few months, we would love that feedback to see where else we can go. And I think we're all quite excited over the possibilities and potential of all of these approaches have for us and for yourselves, obviously, as well. Over to you, Peter.
Yeah, absolutely. I think the feedback point is exactly what I would say also is please let us know, continue to let us know exactly what you need. The reason we've created, even since the last webinar we did, that QLabs Classic package is because of the feedback we've got from customers and from our partners looking for a solution that was more entry level, more basic, more exactly what was required. And we're continuing to try to build those packages to craft exactly the solutions to meet your needs, whether it's, I'm seeing lots of questions about Python, C++, ROS compatibility. we're hoping to do all of those things, but as you can imagine, it's a matter of prioritization and a matter of trying to build the solutions as quickly as we can to meet as many use cases as we can. So if you just continue to let us know what you're hungry for, and we'll do our best to be able to, over time, build the right solution.
Thank you, and thanks everybody for joining us today. And we are looking forward to seeing you at one of our future webinars. Have a great day and see you soon.